Okay, so let's continue. I was having some trouble dragging this point, but in fact, it's fine. The tracking's off a little bit on this monitor. It's kind of weird, but everything works good so far. I have my piece of paper. I have my cutouts. The cutout size is controlled by this slider. Everything is good. So what I'm going to do now, I want to calculate the volume of the box when it's folded, and I want to create a sketch of that, a plot of the volume of the box with respect to the side length of this cutout. So I think that's where we ended in class today. So I'm going to move this over a tad. I need a little bit of more room. So here's what we'll do. Somehow I need the if you look over in the sketch, I need the width, the length, and the height of this box. And it turns out that the width is going to be the entire width of the paper minus these the dimension of these two cutouts, the width of these two cutouts, and the length of the box, this part right here, is going to be this entire length of this paper, the height of it, I guess I would call it, but subtracting off the side dimension of each of the cutout squares. And then the height of the box is literally the side length of one of the cutout squares. So let's do that next. I'm going to create some variables here. Let's call one of them, well, first of all, let's see what length that is. If I hover over that, this is called width, this is called height, and then that length of the side of the square is literally called box height. So I'm going to create a new variable called, how about box volume? And that'll actually be the height times the width times box height. Just hit enter. That should appear up here, right there. We're going to open up, if we go under the view menu and pick graphics 2, I'm going to create a plot of this volume over here in the graphics 2 window. You can hit the shift button and hover over the axes to resize them. I'm going to do the same thing over here. Let's create a new point. If I click in graphics 2, so that's the active window, and I define a point P to equal box height, comma, box volume, that should plot the volume with respect to the box height. Hit return, there it is. I'd like to see the coordinates here, so if I go to object properties, I can have it show the name and value of that point. It's kind of handy to do that. And when I drag on the slider, notice that that plot changes. So I think that looks good. I'm a little surprised that it's not, doesn't appear to be curving. It looks linear. Yeah, height times width times box height. That should be a cubic. I'm just going to trust that for a moment, and then I'm going to go to create a curve that this traces. The easiest way to do that is to use the locus tool. And a locus is actually a tracing generated by slide. In our case here, generated by a point and a slider. So if I create a variable called, say, the curve, let's define that to be the locus generated by point P by the slider box height. And that locus should appear. Ah, look what happened. The locus is in the wrong window. So if I click on him and go to Object Properties, I can actually go to the Advanced tab and make sure that he's in Graphics 2 view, not Graphics 1. I don't need him in 3D view either. So we'll uncheck that. We should now see the curve right there. Now what I'm wondering is why that looks so darn linear. I wonder if I messed up. I think I probably did. So that doesn't look right. So I'm going to investigate that a bit, but that's basically the process of creating the curve and the point along the curve. I'll be back in a minute. We'll upload this and then I'll tell you what I did wrong and we'll be on to the next part, looking at the 3D plot.